Okay, you have your work with you. Now let's double check what you have. We have done the first part, and the first part shows that the mean and the standard deviation are almost the same. Yeah, the mean and standard deviation are very close to each other. You expect that the graph also have a shape which is very close to bell-shaped curve. Now we are going to look at the data set number 2. Data set number 2, if you just put them into a table again, this is what you see. Did you get this? Double check your work. Did you get this? Then what is the mean and standard deviation? You have the mean, which is root 3 divided by 30. You have 20.77. And when you calculate your median, the index will be the same, so I did not repeat everything. You just use the same index, 15 and 16. So you get 20, 19 and 20. So this 19 is a 15 number, 20th is the 20 is a 16 number. So the average of these two will give you a 19.5. So 19.5. So you look at these two, 20.77 and 19.5. The mean seems to be higher. So when the mean is higher, you plot this graph, you will get a histogram which looks like this. What is the shape? It's longer on the right hand side, right? It seems to be longer on this side, so it is a right skew. The shape is right skew. Got it? Give it a minute. So from the value of the mean and value from the median, you can see the mean is larger than median. So you find the percentage of large, the higher number, it shows you about 6% higher. So even though it's just a little bit higher, but you can see from the graph that it's obviously it is right skew. Okay, so from the two values, you can know that it's slightly right skew. So you confirm by drawing a graph, and indeed it is right skew, longer side on the right hand side. Now we go to the next data set. The next data set, this is the tabling. Did you get the right frequency? Make sure your frequency is correct, otherwise your graph will be wrong. Then we'll move on to finding the mean and standard deviation. Oh no, mean and median, right? So the mean is this. 730 divided by 30, we got 24/33. Median, 26. So look at these two numbers. Mean is smaller. Mean is smaller will lead you to a left skew. So when you draw this graph, you find that the higher side is on the right hand side. Okay, so you get a graph which is left skew. You have a long side on the left hand side, but just very short on the right hand side. So this graph is left skew. The difference is not really a lot yet, but you can see a very obvious left skew already. Yeah, so if you have a higher difference, then you see that the skewness will be higher also. Okay, so this is the graph. Any question? So what is the takeaway for the first half of this? What did you learn? We actually emphasize this slide. I know this slide is a little bit difficult to comprehend, so I put it up in a real number in a data set so that you can see the number by your own. The mean is bigger than the median, so you get a right skew graph. The mean is smaller than the median, you get a left skew graph. If the mean is almost the same as the median, then you get a graph which is almost symmetrical. So this is what is I try to emphasize to you in the first half of this tutorial session. Clear? Now I think by now you'll be quite expert to draw this histogram as well as filling up this table. Am I right? Okay. So indirectly you learn this. Right. So at the same time, you also revise a bit on the quantitative or qualitative, whether it's discrete or continuous. You also revise a little bit on the nominal, ordinal, interval, and ratio level. Okay. Yeah, that's all. Right. So this is about topic one. Topic one. Yeah. A little bit of topic two when you have the mean and median. Apart from that, they are all topic one. So now you go down to the very bottom. We have a data set. You calculate this, then I give you 5 to 10 minutes. If you have not calculated this, please calculate it now. Right, then I'll tell you what is so interesting about this this set of data. Okay, right, so you calculate first. Take about 5 minutes. Okay, are you done? It's about 7 minutes already. So I'm going to discuss this, yeah? Mean. So the whole thing we have done it. Just point out to you what is so special about this compared to what you have in your tutorial exercise, yeah? So x bar equals to summation of x divided by n. So what would be the x bar? The summation of x. For this particular set of data, you sum up all the numbers, it gives you 216. Am I right? We have 12 numbers. Okay, so that will give us 18. We got 18, do you? Next, we're going to do the data array. Data array means the number, the data that you have, you sort it from the smallest number to the highest number. We call that data array. Okay, so if you use the first method that we have, which is the easier method, basically you just need to cancel things. So you just cancel 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now you end up with in the middle of these two. So what's the median? Here, right? Will be 18 plus 19 divided by 2. So you get 18.5. This is the first method. Okay, what's the second method? The second method is using the I formula. So we know there are 12 numbers, so the n is 12. So the I will be half of 12, which is a 6. Now you get a round number. When you're using this formula, you get a round number. That means you're going to get the sixth number in the data set plus the next number. Okay, then you divide by 2. So what is the sixth number? The sixth number is 18. And then the seventh number is 19. So you still get the same answer, which is 18.5. Yeah, hopefully you got it. It's almost the same as what you have done. Now we're going to look at mode. How many modes we have? We do have a few numbers which are repeating. 13 no, 14 no, 15 no, 17 no, 18 got 2, 19 got 2, 20 got 2, 11, 21, 22 don't have. So 18, 19, 20, all of them appear twice. So what is the mode? The mode will be 18, all of them, 19 and 20. Everyone appear twice. They have equal number of occurrence. So all of them will be the modes. Okay, now come to range. Range is you take the highest number, or you call the maximum, minus of the minimum number in the data set will give you 22 minus of 13. So you get a 9. Very straightforward. This is 9. The next number that you have is variance. So you can refer to your formula sheet where you are given a standard deviation formula with a square root sign, but we just take away the square root and find the variance first. What is the n? N is this. Okay, n is this. Look at the mean, 12. Then this is a summation of x. You add up all the x's, you should get 2, 1, 6. So you get 12 here. You don't know what is it yet. And n is 12. And you have 12 minus 1. And this is 2, 1, 6. Okay, 2, 1, 6 come from the top here. 2, 1, 6. You add up all the numbers, all the 12 numbers, you add it up. You should get 2, 1, 6. So let's find out what is the summation of x squared. Summation of x squared, you get a summation of x squared will be, you just add what is the, it doesn't matter you add from the smallest to the highest or you add from the original, it doesn't matter. Okay, let's say we use this one, 13, 14, and the last one is 22, right? So basically you just directly press your calculator, 13 square, then you plus, then you 14, then you press a square, then you plus, then you continue until you get the last number. What did you get? This is what your number, 3974. So what you do is you just put in 3974 over here. The next step is just press your calculator. Then you get 7.82. This is called variance. Standard deviation is just the square root of this variance. Square root this. And you get 2.80. Did you get that? Yeah, this is a calculation that you need to know in your quiz. Yeah, in the exam. Very basic calculation that you need to know when you study statistics. And also, what does that mean? Yeah, the other day I explained to you what standard deviation mean, right? It's just the average distance of the data from the mean. The mean is 18, right? The mean is 18. Yep, the mean is 18. So what's the distance, the average distance of the rest all of this data set, data values deviate from 18? How far are they from 18? Here it says about 2.8 steps away from 18. Yep, so 2.8, about 3 here, about 3 here on average. Okay, right, the last part of the question asks you to calculate interquartile range. So we got to find out what is Q1 and Q3 first. So let's find out Q1. Now I need to leave some space here. You have Q1. The I will be P over 100 N. So you will be 25th percentile, and you have 12 numbers. So you get a 3. A round number. So what should you do? The third number plus the fourth number divide by 2. So what is the third number? The third number is 15. The fourth number, 17. So you get 16. You do the same thing for Q3. So I equals to now 75. If there's a repeated formula, you can just write once. So you get 3 times of this. So your Q3 will be the 9th number plus the 10th number. You divide by 2. So what's the 9th number? The 10th number. So you get 20. That's how we find the IQR. Interquartile range will be Q3 minus Q1, which is 20 minus 16, and you get a 4. Okay, now I want you to look at this set of data with the set of data that you have in your tutorial. This is your tutorial, right? Look at question number 3. Okay, look at question number 3. They look the same. I just highlight it. Put a brown color. Okay, so this is what I asked you to look at. You also have 12 figures. You compare the number here and the number I gave you. What's the difference? And the number I gave you, which is here. What is the difference? 7, 8, 9, 17, 18, 19, 12, 11, 10, 22, 21, 20. Then 8, 10, 4, you get 18, 20, 14, 9, 5, 3, you get 19, 15, 13. So what's the difference? I think some of you spot the difference already. The one I give you is 10 more than what you have here. Correct? Okay. So you notice the answer? Do you notice the answer? This set of data, the mean is 8. The median is 8.5. The mode is 8, 9, 10. This set of data, the mean is 18. Median is 18.5. And the mode is 18, 19, 20. So what's the difference? Seems that every number of these has been added by 10, correct? So you see that when you have a set of data, if you add consistently the same value to each of these, it will make the center shifted by that much. The center is supposed to be around 8, 8.5, 8, 9, 10. Then you add 10 to each of these values, the whole center shifted to the next, to the next area, okay, the next location. Now how about B? What did you see in B? Range, variance, standard deviation. What's the range? 9. What's the variance? 7.82. Standard deviation? 2.8. You look at this, what's the range? 9. 7.2 is a variance, sense that the deviation is 2.8, exactly the same. That means if you have just added an amount to the original number, there will be just a shift of all these numbers to another location. Instead of centered around 8, now it's centered around 18. How about the spread? No change. The spread remains the same. So you see that there's no change in the spread. The spread is still the same. The spread is still the same. Okay? And what happened to the IQR is also considered spread, right? So what happened to the IQR? Same, no change. Right? Did you see something here? Right. So if I were to give you 27, let's say I add 20 here, now becomes 27, 28, 29, then 32, 31, 30. This one is 28, 30, 24, 29, 25, 23. So I add another 10 for each, right? What would be the mean? The mean will shift again to the higher side. Yeah, I add 10. So the mean should be 28. The median should be 28.5. And the mode will be 28, 29, and 30. What happened to the range and the spread? They won't change. They still remain at 9, 7.82, and 2.8, and it's still a 4. Okay, so that is something, no, you just need to notice and just bring it up to you. Right, so at the same time, you just practice once again how you do all this measurement. Right, so these are the important calculation that you need to know in your quiz, in your exam. Right, clear? Okay, now we are done with the tutorial, the exercise for this tutorial. Now I'm going into the tutorial questions. Okay, I'm going into the tutorial questions that I say I will do it during the tutorial session. Right, so do you have a tutorial with you now? Okay, going backward, right? Going back from topic 2. I don't need to go through all this because they are almost the same. And this answer will be 68%, right? The other day, most of you, I think majority would say 68%. Plus minus 1 standard deviation is the empirical rule. So we are done with topic 2. We go backward to topic 1.2. Okay, the second half of topic 1. We are done with this. I showed you the answer already, and we are done with this. I also show you the answer. Now, have you drawn your graph? I show you the answer, right? Question 2. This is the answer for the tabling frequency distribution for this. Right, so now I'm going to go through this with you, histogram and polygon and ogive. If you look at the figures, 4, 6, 8, 9, 3. Can you tell me what shape is that? If you were to draw a histogram, how does it look like? What is on the x-axis and what is on the y-axis? The x-axis basically is the class, but you don't label as class. What is the story about? The story is the number of points scored. Okay, online game, number of points. Right, so that is the x-axis label. And what will be the y-axis label? This will be the frequency. Okay, so I'm going to show you the answer for histogram, for polygon, and for ogive. Just check against your working. Okay, I need to put in the story. I don't have a labeling for the x-axis. It is the number of points for online game. Okay, the score is here. Okay, so you can have a more comprehensive title if you want, or you can also put it here is number of points scored for online game, or you just put the scores here, or you can put the comprehensive title is the number of points scored by for online games, right? So just now this was hiding it, covering it. Okay, the scores is here. So I asked you what will be the shape. Did you notice that this side is longer? So this is left cube. So this is a histogram for question number 2. Double check your work and see whether you got it. Okay, if you have made any mistake or whatever, you can just take a snapshot or you can just review this later. Right, so I will go to the next one. Polygon. You see the first one, 51 to 57. If you draw a polygon, you need to draw it in the middle. Right, so what is the middle point? 51 to 57, the middle point is 54. So you're going to put 54 as number 4 here. Okay, so 54 as 4. 61 as continue, 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 continue. Then 2 boxes each extend to the left, 2 boxes extend to the right. This will be the 2 anchor for the polygon. So this is the polygon. Got it correct? Now we move on to ogive. Right, before I move to ogive, let's look at the table first. The table shows 51 to 57 is the first class. The second one is 58 to 64. So for ogive, we only take care of the higher number. 57, 64, 71, 78, and 85. Okay, so this will be the number shown at the x-axis. Then the cumulative will be on the y-axis. Okay, so this is what you have. 57, 64, and so forth. The x-axis. And the y-axis will be the cumulative frequency. The highest number is 30 because there are 30 numbers there. The first number is this. So this number again is an extension. 2 boxes to the left and connect it to 0. It is okay you put here or you can put it down here, right? I mean, if you shift over here, that means everything will be shifted one box, okay? Not only this one, right? So if we start here, then it will be 2 boxes each. So this is ogive. Okay, now we go to the next question. The next question is all about the weights in kilograms of 50 NBA basketball player. So this is the one that I've already shown to you. Okay. Okay, I think I missed out something. I did not show you how you calculate the classes, right? Okay, there are 30 numbers here. 30 numbers. Okay, I just show it here. There are 30 numbers here. So you need to find out 2 to the power k, which is greater or equals to 30. So our experience, Let's start from k equals to 4. So let's say k equals to 4 is 2 times 2 times 2 times 2, give you 16. Still less than 30. Nope. 2 to the power of 5 is 32. So it's just over 30. So k equals to 5. Okay, so k equals to 5. So answer this number class required. Next, find the suitable class width. You have smallest number, which is the smallest number, which is the smallest number, the 85, 51 to 85. Okay, 51 to 85. Okay, 51 is here. 85, is it the biggest? Yeah. Okay, so you want to find the suitable class width. You need to take 85, the biggest number, minus of the smallest number. Then you divide by the number of classes that you recommend, which is 5. So how much you get? 85 minus of 51. Then you divide by 5. So round up to the next round number, 7. Every class must have 7 numbers. So if you look at this class, is there 7 numbers? You have to count 51, 52, 3, 4, 5, 6, 7. So there are 7 numbers. Okay. So from here to here also 7. From here to here again 7. From here to here also 7. Okay, so this is how you define the class width. So the first initial class will be given to you as I mentioned to you. So you just use it and continue on. Now I go to the next one. Same thing here. Let me see the smallest and biggest number. 75 to 165. 75 and the biggest number 151, I guess. That's the biggest of all. Okay. So how many class needed? 2 to the power of 4. Just now we start with 16. Now we have 50, right? So you got to find out 2 to the power of k must be greater or equals to 50. So if 4, it is still less than 50. If you put 5, 32 is still less than 50. If you put 6, 64, okay, more than 50. So k is 6 classes. So we need 6 classes. So the number of classes will be 6. And what is a suitable class width? The smallest number and the biggest by 6 classes. So how much you have? 151 minus of 75 and you divide by 6. You get 12.67. So 12.67, if you round up, it gives you 13. Now this is the minimum class width that you should use. You can use something bigger, like what I've given you. You can use 15 if you want to. But if you want to use 13, no problem. Okay, but you have to follow the question once this question given you. But if this is your own data and you're going to come up with your own tabling, your own frequency distribution, if you use 13 or you use 14 or you use 15, they are all fine. Okay, so since you are given already, so we're going to start out with 17 to 90. Clear about this? This is how you find out the value K and find out the class width. And this is a table with all the numbers I given you the other day that you are required to draw, histogram, polygon, ogive. Okay, back to, you see that this one is sharing, right? 75, then under 90 and 90, they are sharing the border. So this is how you're going to draw them. You're going to share the border 75, 90, 105. Is this not bell shape? Not really, if it's skewed, also not really. So this graph is a bit not so common. Yeah, probably a little bit of left skewed because left side got more things, suddenly drop down and nothing. Okay, anyway, the question did not ask you to define the shape, right? So this is what you draw for your histogram. It should be a weight and put in the kilo, kg. Put in kg. So when you are drawing polygon, you got to use a middle point. So 75 and 90, you have your midpoint, and the midpoint will be just 82.5. So you start out with this, you start out with this, this. Don't forget the anchor. 2 steps, 2 boxes. Here, 2 boxes. This also 2 boxes. Yep, so this is a polygon. Let's look at the last graph, ogive. So again, I move up first. This is the upper limit of each class, 90, 75 to 90, 90 to 105. So you're going to take the upper limit of each class as the x-axis on the ogive, okay? Start with 90, not 75, yeah? 90 and so forth. Then you draw everything. Don't forget that you're going to extend to the 0 point here, to the y level, which is 0. That is a special feature of ogive. So there are 6 graphs here. Did you draw it correctly? Okay, we are done with this question. Let's move up further. So you're done with this. You're done with this. This one no need to draw graph. Okay, so we are done with this. We move upward. Okay, now this is the sampling technique. How do you know which is which? I asked you to go and do first, yeah? Random, that means it's like you don't have any grouping. It is like lottery style. Just put 10 marbles and you just pick one of the marbles. So every marble is randomly picked and every marble have equal chance of being selected by you. So you look at A, B, C, D, E. Which one has the word random or random number? Okay, so this is random. The nursing supervisors are selected using random numbers to determine annual salaries. So this indicates that the person who doing the sampling follows the simple random sampling. Next, let's find out the next one. Systematic. Systematic is systematic, the hundredth, the fifth, every hundred, every 200. Yeah, so which sentence you see this? Every how many? Every 7, every 100. Okay, so this indicates that the person who do the sampling follows systematic sampling technique. So every 7 customer entering a shopping mall is asked to select his or her favorite store. Every 100 hamburger manufactured is checked to determine its fat content. Right, let's look at others. What else do we have? Stratified. Which is stratified? Stratified is a grouping which has a characteristics. But the characteristics cannot be geographical area, right? It cannot be area. So which is the one? Yeah, E. Did you select correctly? Mail carriers of a large city are divided into 4 groups. What is the 4 grouping? The grouping is by gender and according to this, okay, whether they walk or ride. So this is the characteristics of the grouping. So this is called stratified sampling technique. They group this, who are they? These are the group, it's like postman in another word, yeah, mail carriers are postmen. So you're actually grouping them into 4 groups: male walk, male ride, female walk, female ride. 4 groups altogether. Right, so now you only have 1 left, correct? Okay, so definitely the A will be the cluster. But are you convinced? It says the large school district, all teachers from 2 buildings. Okay, a keyword is here. 2 buildings are interviewed to determine whether they believe the students have less homework to do now than in the previous years. So the keyword is 2 buildings. So you only look at location. So that is called cluster sampling. Okay. Okay, now we move on to the very top where it is about descriptive statistics or inferential statistics. Let's look at descriptive statistics first. Basically, when you look at descriptive statistics, the key feature you see is it must be in past tense. Past tense, over already. So for example, I want to describe how long do you take to finish a task. How do I know? You must have finished the task, then I know how long you take, right? So when I report that, I take a sample of 20 students and I find that the average number of minutes they use to finish the task is 17 minutes. Yeah, they take an average of 17 minutes to finish this task. So how do I get the 17 minutes? Definitely you have to finish the task first, then only I can make a statement out of what I find. So it's over, past. Can you identify which of these are past tense? See that? B. In a sample of 100 on-the-job fatalities, 90% of the victims were men. It is a very simple statement. saying that you have collected 100 numbers and it's about the someone died because of working. And what happened? You say 90% of the victims were men. Yeah, probably in the construction site. So this is just a statement after you have collected the data and you just put your finding a statement form. So this statement is called descriptive statistics statement. See, you collected some data in 1996 and you find that the expenditure for the cable industry were this much. So it's just a statement. And you find that statement are quite clear. Yeah, they are quite detailed in the sense that they tell you what is it. Next, the average stay in the hospital for 2,000 patients who had circulatory system problem was this much. Again, there are 2,000 patients. These 2,000 patients cannot be population, right? It should be sample because we should have more than 2,000 patients in a country. Then, and these are having these people are having circulatory system problem. And how long they stay in the hospital? 4.7 days. This is just a rewriting your findings in a statement form. So this is called descriptive statistics. Now we move on. No more already, right? No more past tense. So we move on to the next one. So the next one is inferential statistics. Okay, so what is inferential statistics is you are going to talk about estimate about future. Remember, you find that the bubble tea, the average price of the bubble tea for 30 is $3.50. So you estimated that the whole of Singapore, the bubble tea average price is $3.50. Okay, right. So you're actually predicting something, telling something ahead of time. Right. So that is called inferential statistics. And you would see, I may say, future tense. Future tense. What is future? Something to tell you about the future. So which of these statement has future tense? Okay, A, 2040 is not now, it's future. And the other word that you can see is will. H, may, soon. Soon means have not arrived yet. So by 2040, at least 3.5 billion people will run short of water. An expert says that mortgage rate may soon hit bottom. How much? Don't know. Right. So that is a feature, characteristics of these inferential statistics is sometimes they are quite clear. For example, it says 2040, quite specific, at least 3.5 billion people, yes, and run short of water. They are quite specific. But the last one may not. It says the rate may soon hit bottom. What is bottom? We don't know. Right. So this is a characteristics of inferential statistics statement where sometimes it is quite general. It is very general. They give you an information, but the information is not clear, not specific. Okay. Now, what is the rest? The rest is not past tense, it's not future tense. What are they? They are present tense. So present tense can be this, can be that. It can be two. So how do you recognize? Then you have to recognize whether the statement is general or not. If the statement is very general, you are trying to understand, you're trying to figure out what it's trying to tell me. That is inferential statistics. If the statement is very clear, then it should be descriptive statistics. So if you look at look at G. Look at G, past tense, right? Is it descriptive of inferential? Think over that. National average annual medicine expenditure is this much. Is it clear? Quite detailed? Yes. It sounds like after you collect the data, then this is what you write. Okay, you just summarize what you find, and this is what you write. So this is descriptive statistics. E, allergy therapy makes bees go away. So this is present tense. Did you learn a lot of things by this sentence? Or it sounds very general. You don't really know what is it. You try to understand, but seems like there are a lot of things not told. Right. So this type of statement is very general, and this will be inferential statistics. F, drinking decaffeinated coffee can raise cholesterol levels by 7%. It sounds like inferential or sounds like descriptive? Can raise. So the can is a present tense. Just think back. If you have collected data, and from your data you find that drinking decaffeinated coffee raise cholesterol level by 7%. You would just write drinking decaffeinated coffee raise cholesterol levels by 7%. You don't really need to put in the word can. So that word can seems like maybe, probably, right? So you are not very sure. That indicates that it may be inferential statistics. This is a bit tricky. Yeah, F is a little bit tricky. Got it? Okay, so that's how you actually identify this descriptive or inferential statistics. Now, how to use it? It's very common in everywhere. When you're on the public transport, in MRT, on the bus, reading the newspaper, reading magazines, or you just look up any news, any advertisement, you will see statements like that, or even news. Yeah, you will see statements like that. So you know, after now going through this, you roughly know, well, are they referring to the sample or are they referring to the population? Okay, descriptive referring to the sample, right? Inferential is to estimate the population. Remember? Okay, so you can know from that statement whether someone is trying to describe a sample or that someone is trying to make an estimation, make a conclusion about the whole population. Right? Okay, so we are done with all the questions in topic 1.1, 1.2, and I didn't go through topic 2, but you should be able to do all the questions in topic 2. Okay? Right. So our next lesson will be next week. So within this week, I will have some quizzes for you for practice. Okay, for you to practice your quizzes for topic 1 and 2. So I will put up in an announcement once I have put it in. Clear? Okay. So I stop sharing first. Then do you have any question?